Hi, this is Mel with We Can Code It, and I'm going through some common programming test or interview questions that you might see. And the point here is to learn through the test. It's not to figure out a precise answer to a test question you might see, because guess what? These values are going to be arbitrary. The concepts are what we're looking for here so that you understand order of operations, and in this case, short-circuiting evaluation, as well as prefix and postfix notation, so that you can evaluate them in your brain so that you know what the computer is going to do. Cool. So right here I'm at indiabix.com under Java Programming Operators and Assignments. I am on number 7 and just asking us what the output of the program will be. It's giving us some multiple choice answers. Oops, I hope you didn't see the answer. But you won't need these because you're a programmer and you could figure this out on your own. Because this is in Java, and we Can Code It, we have both Java and C# students. What I'm going to be doing is translating this over to C#. You'll notice the languages are very, very similar. So let me go ahead and copy this. I'm going to throw it into my IDE, which is Visual Studio. And Visual Studio, I have a console application ready to go here, and it's using C#. There are a couple things we're going to have to change between Java and C#, one of which is lowercase main becomes uppercase main in C#. So main is the front door to our application, and when it's in Java, you need this to be lowercase. In C#, you need this to be uppercase. All right. The other thing we're going to fix here is this system.out.println. Now, Java folks, you know this is it will print out to the console. C# folks, I hope that you see this and can deduce that this is the same as system.console.writeLine, because it is. All right, if you didn't know that, now you do. Great. Looks very similar between the two languages otherwise, doesn't it? Yes, because they're both C-based languages. They're both come from C, the syntax does. All right. We're going to hop into main here and start evaluating ourselves on line 9. So let's look at lines 9 and 10. Lines 9 and 10 are both initializing variables. The variables are x and y. They're integers. We're initializing them to the value of 0. And then we hop into our for loop. You can see the opening body of the for loop right here and the closing of the for loop here. Okay, there are 3 parts to running a for loop: the initializer, the conditional statement, and the updater. The initializer is run once and only run once at the beginning of our for loop. The conditional statement is evaluated once before every iteration that the for loop is run. So it happens before we hop into the for loop. And then the updater gets run once for every iteration of our for loop. I always think about it happening right here, right at the end of the for loop. All right, let's start this thing. Z is equal to 0. Great. Notice Z is sort of like a counter, we could tell, because this is a very standard pattern we'll see with for loops where you have something that initializes a value and something that updates it by 1. These may change. You might see Z equals Z plus 2 sometimes. You might not see an initializer. The initializer might be in the parent scope here. So it could be here. That's legal too. And you might see, oops, we need a semicolon. That's why it's yapping. So you might see stuff like that. Okay. If you do, don't freak out, right? This is legal. It just means Z is now has a larger scope than it did before. Before it only existed in the for loop. If I moved it out here, it exists in this whole method. Let's put it back to the way it was. Okay. Z is 0. Is 0 less than 5? That is true. Because it is true, we hop inside the body of our for loop and we continue evaluation on line 13. Here's the tricky part. We have an if statement. This should look pretty familiar to you. What's interesting about this if statement is that there's an and, a logical conditional and operator here. So it needs both. And means both the left and the right conditions need to be true in order for the statement to be true, in order for it to go inside the body of the if. Okay? So, because there are 2 sets of items in parentheses, we start at the left and we evaluate. This is called a prefix operator. You'll notice prefix and postfix do similar things with slightly different twists. We've typically seen postfix operators at the end of our for loop as an updater. Now we're seeing this prefix operator. You might also see a postfix operator here in a conditional statement. So prefix and postfix are pretty cool because they allow us to do two things at once. They allow us to, and I'm just going to write comments above here for you. A prefix, which is something like plus plus x, when you see the plus plus before the variable, what that does is it adds, in this case, adds 1 to the variable before any other operations occur. Okay? And then step 2 in this would be, then it evaluates other expressions on a line in a statement. Okay? So let's look at this as a statement. This is a statement. What do we have here? We have the prefix operator that adds 1 to x, and then we have another evaluation, which is that greater than 2? So when you see prefix, it adds 1 to your variable before anything else happens, before anything else is evaluated. If this were postfix, something else would happen. We would, postfix does it the other way around. It evaluates first, and then it adds 1. Okay? So if this were postfix, it would evaluate, is x greater than 2? It would do that first, and then it would come back and add 1 to x. So they can give you very different results, very different results. So that's the difference between prefix and postfix, and it's an important difference in this type of scenario. The other thing we're going to pay attention to is something called short circuiting. Okay, I'll show that to you in a second. So let's first evaluate this. Plus plus x. Because it's a prefix operator, we first add 1 to x. X is now 1. Is 1 greater than 2? That is false. 1 is not greater than 2. Because this is false on the left-hand side here, we short circuit the remaining part of our expression here. We never get there. Why? Because this conditional and statement requires both the left and the right side to be true. Because the left side is false, we don't need to evaluate the right side, and indeed, we don't. We never get there because it's a waste of resources for the computer. So we only add 1 to x, and then we hop out. We jump over the rest of the if statement down to this line, and we're at the end of our for loop here. So let's just write down our values. At the end of the for loop, before we add 1 to z, x is 1, y is 0, z is currently 0. Okay, now we're at the end of our for loop. We're about to jump up again to do it again. So we add 1 to z, right? We add 1 to z, so z is now 1. Is 1 less than 5? That is true. We go into line 13 here and we evaluate. Plus plus x, x was 1, so plus plus x makes x 2. Is 2 greater than 2? The answer is false, so we just jump out of that if statement. And at the end, before we start our for loop again, let's write down our values. X is 2, y is 0, z, oops, before here z was 0, z is 1. Now we add 1 to z. Z is now 2. Is 2 less than 5? That's true. So let's hop over here. Let's do this. Plus plus x. X is now 3. Is 3 greater than 2? The answer is true. Good. Now we can head to the right side of this equation. Now we do a plus plus y. So y is now 1. Is 1 greater than 2? The answer is false. So we do not go into our if statement, the body of our if statement there, and we just jump down here. Let's put our values here. X equals 3. Y is finally 1. and z is 2. Let's add 1 to z. Z is now 3. Is 3 less than 5? That's true. Hop over here, plus plus x. X is now 4. Is 4 greater than 2? Yes, that's true. Now we want to go over to the right side of this expression. Add 1 to y. Y is now 2. Is 2 greater than 2? No, that's false. So let's hop down here. Let's write down our values for ourselves so we can remember. X is 4. Y is 2. Z is 3. And we're back up here. We add 1 to z. Z is now 4. Is 4 less than 5? That's true. Hop over here. Add 1 to x. X is 5. 5 is greater than 2, so that's true. Then the and. Now let's add 1 to y. Y is now 3. Is 3 greater than 2? The answer is true. All right. So we hop in here and we add 1 more to x. Awesome. So right now, x is 6. Y is 3, z is 4. Let's add 1 to z. So z is now 5. Is 5 less than 5? The answer is false. It is not. It is equal, but it is not less than. So now we exit our for loop right down here and we print out the result. So it's either going to be, for you Java folk, you'll see system.out.println x plus y. Oops. Okay, that's what the Java folks will see. C# folks will see this. Either way, they mean the same thing. So what's going to be printed, folks? Do you think it's going to be 6 in a space and then 3? If so, you are correct. Let's double check this. I'm going to run the program. And indeed, it's 6 and 3. We're going to hop back over to find our answer, and we are correct. It is 6 and 3. All right, I hope that helped, and I hope it explained the difference between prefix and postfix, as well as short-circuiting or lazy evaluation, and you'll also hear it called that, of conditional and statement. All right, take care. See you in the next video.